cool. Freedom Trail 514. Let me send a quick link. Yeah, I mean, yeah, and definitely, if I was in competition, I wouldn't spend so much time describing the problem. But I'm just kind of practicing. I think for me, as you and if you watch this, you'll notice that I make. I mean, I like on algorithms, I'm okay, but I make a lot of silly mistakes that I need to kind of practice my way back into getting used to it again. Yeah, cool. Freedom Trail. In the video game 4 no spoilers, hopefully. 4 the quest Road to Freedom requires players to reach a metal dial called the Freedom Trail Ring, and use the dial to spell a specific keyword in order to open the door. Given a string ring, which represents a code engraved on the outer ring, and another string key, which represents a keyword needs to be spelled, keyword needs to be you need to find the minimum number of steps in order to spell all the characters in the keyword. Given a string ring, which represents the code engraved on the outer ring, and another string key. Oh, sorry, I read the same thing as I have just wrote. Initially, the first character of the ring is aligned at the 12th or clock direction. You need to spell all the characters in the string key one by rotating the ring clockwise and or anti-clockwise to make each character of the string key align at the 12th direction, and then pressing the sender button. Excuse me. Feeling a little under the weather. At the stage of rotating the key to spell the key character key sub I or key index I, you can rotate the ring clockwise. It counts as one step. The final purpose is the line at the 12 o'clock direction. Okay. If the character has been aligned, you need to press the sender button, which also counts as a step. Okay. Okay, so it seems like this is my so me redescribing the problem after reading is that basically you're given a lock, I guess, and you rotated left. I don't know if this is on screen, but you rotated left and right to kind of, and then you press a button to kind of spell something or like to access the thing. Okay. And then you just try to spell things out in a minimal number of way. Okay. My first intuition is another dynamic programming problem / memorization. As and hopefully you get your wish here on seeing me doing it recursively. Let me take a look at example first. For the ring is coding. Okay. And you have to move T to thing. One more step for the spelling. What? Oh, to lock in the letter. Okay. Yeah. Yeah. So it screams dynamic programming problem to me. Let's figure out the states. The one I think. So the offset is one state. That's for sure. And let me see. N is 100. So I'm also trying to think. I'm thinking right now about what's the worst case scenario in general for each step. So if the key if the word that we have to spell, like key is the word that I have to spell. Right? Okay. If the word that we have to spell is 100 letters and we have to do 100 letters each, or we have to click on the thing 100 times, that means the worst case scenario is that we need 10,000 steps to get the number right. So that's kind of the worst case, no matter what. So I'm wondering if that's good enough to be a state. Oh God. So right now, I'm probably gonna do this in C, to be honest. Oop. I mean, yeah, as people notice, when I do dive program from, or sometimes even memorization, I love to do it in C, just because my constructs are very primitive anyway, and I feel like it just gives me a little more speed. But yeah, so the offset is one of the states. It's just what is the current direction of the ring, right? So that's one state for sure. Second one, what did I say it was? Well, the character you have to spell, uh, the index of the key index. Is that good enough? Maybe it is. We could spin both directions, right? Yeah, actually, maybe it is. So we'll declare the way. Let's see. I'm just a little lazy, as you know, and if we can, people will know that I add 5, so I get an off by 5 error usually at worst. But okay. So yeah, so we start off by returning with the 0 index, and on the first key, or maybe pre-key, but yeah. Okay, so that's probably how I kick off the thing. There's some, I will also probably change some things just so I could do some stuff globally. Also, what is this? Okay, so we'll initialize the array. This might actually be set up the values, and we set that the max, the worst case is 10,000. So let's just do like 100,000, something big. Excuse me. Okay. So was it min steps? Let's do index actually. So, not I'm not holding to this for now, but I'm going to play around with it, see what happens. Yeah, if I guess I should keep track of. They don't give you. They sometimes give you the string sizes, but okay, fine. Key size. Yeah, then you're good. Then at this step, just return 0. And offset doesn't really matter in this case. If dp index offset is less than. Okay, so these are the base cases, and probably something like this. Minus 0. Okay. Yeah. I think this is straightforward. I mean, I guess as a good submission way, maybe. But now we just do the offsets, right? To how many spins we do. So offset is the current offset that we pass in. Yeah, okay. Is it wing size or key size? I think it's wing size. Okay. So, yeah, okay. Oops. Kind of, not quite, but bear with me. So, if, let's say, if key of I is equal to wing of index, okay. And it seems like, and this will, in this case, I mean, in this case there'll be no dead ends because, well, assumes, yeah, because the key can always be spelled. So this will always activate at least once. So, and I think one thing that in theory we would worry about for recursion is kind of the recursion depth. But it seems like in this case, because max is only 100, that should be okay for with respect to like stack overflows and stuff like that. If this actually statement is not complete yet, hold on, but let me get this out of my head first. If cost is less than min, okay. So this is actually some cost function that takes into I and offset. Okay. What do I call it? New offset? Maybe it's just return. So this one's a little tricky in that, I mean, it's not that tricky, but you're following along anyway, because it's just the difference. Oh, well, and +1 for pressing the button. Yeah. It's either, I just have to make sure I get this right, is absolute value of m, so, and then, or, which is the min. And I don't know if they have all the math libraries, but okay. And this is where there might be an off by one, so I'm just double checking. Was it the wing size? Oops. Oh, maybe yeah, maybe that's just right. Well, let's kind of see if this compiles first. So yeah, so this is the case where like you move it in the direction that's the that doesn't loop over. So like if you're moving from index 1 to 5 or 5 to 1, then it's going to be 4 steps. But if the ring size is like 6, then you can actually go to 5, 0, 1, or depending how you want to do the index. But there's, man, yeah, okay, fine. I always forget how C does min stuff is annoying. Fine, I'll just... was hoping... Also, sometimes I just declare these as macros, but the way I do things is kind of. Oops. Nope. Oh, usually I'm pretty good about it, but this time I am not. Oh no. Boo. Okay. Okay, so we're seeing a buffer over in molecule. Not sure. 111.5. Okay. Don't really do any. Don't really do anything on the heap. Am I missing something? Man, this is barely useful. Okay. Is the way I do the chores. Okay. Didn't we all get even as I messed up on one of the index stuff? Oh, yeah, okay, fine. So this is key size. Wait, is that right? This terminology between key and ring is a little confusing. Sorry, give me a second. This should be ring size for sure, but I'm using the wrong index. Okay, that looks okay. Yeah, I mean they don't really give you another example, so let's play around with. Just spell out something. Okay, I mean, like I'm not confident, but that seems pretty reasonable. That this should be okay. Man, I should have double checked. Okay, well, I should have double checked some edge cases to be honest. But okay, so that actually was easier than expected. Yeah, so in this case, I do do the recursion, and some of it is that we noticed both the size of ring and key is within 100, so you can kind of do stuff like this. And I think, and maybe to be frank, I probably in retrospect could have described the recurrence a little bit better. And this is kind of essentially the recurrence given f of given the index and the offset. You calculate, if the next step, which is you calculate the next character on the which one is key, which one is ring? Okay, the next character on the key, and you know that you either have to move it left or right or whatever, but to the next character that matches the next string, which you're not going to move it to. I mean, you can, and you could write the recurrence that way too, but you move it to the next character that way it matches, and then do a recursive, and then do that recursively. I'm having trouble speaking. Recursively from that. I think Yeah, I think that should be okay. I think the other thing that so this is as we kind of actually, I mean, this was not intentional, but within Deem, if I were to convert this to dynamic programming, what are the things I would think about, right? And actually, this lends itself to very straightforward dynamic programming. The base case, you just have to initialize. Well, yeah, you could initialize all the index at keys. Maybe I want to make a stretch code. Do anyone want to see me actually code this up? If I want to do this dynamic programming, would that be actually be helpful? Uh, okay, well, no one said anything. So, but basically, you just initialize all the array of your, or you initialize your matrix such that when index is equal to key size, you set it to 0, and then uh, and and then yeah, I mean this is the recurrence, and you only ever looking at index plus 1 and I, so this would convert to an I, for I for j loop, where you always only look at I minus 1, and then for each j, if the j is equal to the the index, the keys, the current count that you're looking at, then you calculate the offset, or the cost of that offset, and plus 1, and then you just min over all that way. I think this is actually pretty straightforward to use dynamic programming. I didn't really think about it, and for me, it's more intuitive to do it this way. But do recursion, cool.